Good morning, everyone. My name is Nefi, and today I will be presenting an enterprise network modernization proposal focused on implementing software defined networking, or SDN, and software defined wide area networking, also known as SD-WAN. The goal of this proposal is to address the organization's current network challenges, including rising WAN costs, inconsistent performance, limited flexibility, and increased difficulty managing multiple branch locations. As the company continues to grow, the network needs to become more scalable, more secure, easier to manage, and better aligned with cloud based applications and future business needs. Today I will walk through the current state of the network, the major pain points, the proposed SDN and SD-WAN strategy, recommended technologies, implementation steps, project risks, and the leadership approach needed to make this transition successful. At a high level, the organization's current network has grown faster than its operating model. The company is using a mix of MPLS, broadband internet, fiber, cable, and LTE connections across multiple branches. While the setup may have worked when the company was smaller, it is now becoming expensive, difficult to manage, and less effective during peak usage. My recommendation is to move from hardware-centered WAN model to a policy-driven SDN and SD-WAN strategy. SD-WAN should be used to improve branch connectivity, application, performance, failover, and cost control. SDN should be used to centralize policy, automate configuration, improve visibility, and better integrate the network with data center and cloud environments. The expected result is more flexible network that lowers WAN costs, improves application, improves performance, strengthens security, and supports future growth. The current network is based heavily on traditional networking hardware. Routers, switches, firewalls, and WAN devices are typically managed individually. This means changes often require administrators to log into separate devices, make manual updates, and coordinate with multiple service providers. The WAN environment is also mixed. Branches may use MPLS, fiber, cable, internet, broadband, and LTE backup connections. Having multiple transport types is not necessarily bad, but without centralized control and visibility, it becomes difficult to manage performance consistently. As the company has expanded into more branch locations, the support burden has increased. Each new site requires custom setup, provider coordination, security configuration, routing, changes, and troubleshooting. This creates slower deployments, higher operational costs, and a greater chance of configuration drift between locations. Overall, the network is functional, but it is not optimized for current business growth. The main pain points are cost, manual configuration, limited visibility, congestion, and branch expansion. First, WAN costs are high, especially where MPLS circuits are used heavily. MPLS can provide reliability, but scaling bandwidth with MPLS is expensive compared to broadband or fiber internet. Second, manual configuration increases the risk of human error. When changes are made device by device, there is a higher chance of inconsistent settings across branches. This can lead to outages, security gaps, or longer maintenance windows. Third, limited visibility makes troubleshooting harder. If an application is slow, it may not be immediately clear whether the issue is caused by the provider, the WAN link, the branch device, the cloud application, or congestion. Finally, peak congestion affects user experience. Critical applications may compete with normal internet traffic or large file transfers. From a business perspective, these technical problems translate into lost productivity, delayed branch onboarding, and higher support costs. So, why change now? The reason this modernization matters now is because the business environment has changed. Many organizations are moving away from a model where most traffic goes back to one corporate data center. Instead, users are accessing SaaS platforms, cloud services, collaboration tools, and remote applications from many different locations. This creates new demands on the WAN. The network must support cloud first applications, hybrid work, stronger security expectations, and faster operational changes. For example, video conferencing and voice traffic need low latency and low jitter. Cloud applications need reliable internet access. Remote and branch users need secure access without unnecessarily backhauling through a data center. Traditional WANs were not designed for this level of flexibility. SDN and SD-WAN provide a more modern model by allowing the organization to manage traffic based on business priorities instead of relying only on static routes and physical circuits. So, what is SDN? Software defined networking, or SDN, separates the control plane from the data plane. In simple terms, the control plane is the part of the network that decides how traffic should move. The data plane is the part that actually forwards the traffic. In traditional networking, each router or switch makes many of these decisions independently. With SDN, more of the decision making is centralized through a controller. This allows for administrators to define policies from a central location. Instead of configuring each device separately, the controller can push consistent policies across the environment, automate changes, and provide better visibility into network behavior. The executive value of SDN is that it reduces manual effort, improves consistency, supports automation, and creates a stronger foundation for future network innovation. Instead of managing the network one device at a time, the organization can manage it based on business intent and policy. What is SD-WAN? Software defined WAN, or SD-WAN, applies software defined control to wide area network connections. Instead of forcing all traffic to use one fixed path, SD-WAN can evaluate multiple paths such as MPLS, broadband fiber, cable, LTE, or 5G. It can then choose the best path based on application requirements and current link conditions. For example, voice and video traffic can be sent over the lowest latency path. SaaS traffic can go directly to the internet through a secure connection. Backup traffic can use a lower cost broadband path instead of consuming expensive MPLS bandwidth. If one link fails or becomes congested, SD-WAN can automatically move traffic to another available path. This is a major improvement over traditional WAN architectures because it makes the network application aware. The WAN can now make decisions based on performance, business priority, and user experience. The proposed architecture combines SD-WAN at the branch level with SDN in the core and data center environment. At each branch station, SD-WAN edge devices would connect to available transport links such as MPLS, broadband fiber, and LTE. These edge devices would build secure encrypted tunnels across the available links. A centralized controller or orchestrator would manage policies, application routing, monitoring, and configuration templates. The organization would still be able to use existing infrastructure during the migration. This is important because we do not want to create unnecessary downtime or force an immediate replacement of everything already in place. The strategy is to deploy SD-WAN as an overlay first. That means the new intelligent WAN layer can run on top of the current circuits. After performance is validated, the company can decide which MPLS circuits to keep, reduce, or replace. The key components of this design include the SD-WAN controller, SDN controller, branch edge appliances, encrypted overlay tunnels, analytics, dashboards, and centralized policy engines. The network would use technologies such as VPN, IPsec VPN for secure tunnels, TLS or DTLS for control communication and routing protocols such as BGP or OSPF to integrate with existing routing environment. Quality of service, application identification, logging, and API integration would also play important roles. The main design principle is business continuity. The migration should not interrupt critical operations. Instead, the organization should begin with a controlled overlay deployment, validate application performance, and then gradually shift more traffic to the SD-WAN fabric. Another important principle is security. Public internet links can be used safely, but only when combined with encryption, segmentation, access control, and monitoring. For SD-WAN, my primary recommendation is Cisco Catalyst SD-WAN. This solution is a strong fit for a large enterprise because it provides centralized policy management, routing strength, cloud connectivity, visibility, and scalability across branch environments. For SDN in the data center, Cisco ACI is a strong option, especially if the organization has a complex data center environment and wants application-centered policy control. VMware NSX is another strong option if the organization is heavily invested in VMware virtualization and needs software-defined networking and security for virtual workloads. Fortinet Secure SD-WAN is also worth evaluating, especially if the company wants a security-focused WAN solution and with firewall and SD-WAN capabilities integrated into one platform. Final recommendation is to deploy SD-WAN first because that is where the clearest business benefits are: lower WAN costs, better branch performance, faster deployment, and improved resiliency. The recommended platform stack begins with branch connectivity through Cisco Catalyst SD-WAN. Central orchestration would be handled through Cisco's SD-WAN management platform. For the data center and core environment, the company would use Cisco ACI or VMware NSX, depending on the current infrastructure and long-term virtualization strategy. Security integration is also a major part of this stack. SD-WAN should not simply make traffic faster, it should make traffic faster and safer. That means integrating the next generation firewalls, identity and access management, SIEM logging, and potentially SACE or cloud security services. The reason for starting with SD-WAN is that it directly addresses the biggest business issues: branch costs, application performance, uptime, and operational complexity. Once the WAN foundation is improved, the organization can expand SDN deeper into the campus, data center, and cloud environments. The expected benefits and success metrics of this project should be measured by business outcomes, not just whether the technology was installed. The first expected benefit is WAN cost optimization. Organization can reduce dependence on expensive private circuits where business-grade broadband can safely support traffic. Second benefit is improved application experience. SD-WAN can prioritize voice, video, collaboration tools, and cloud applications based on latency, jitter, packet loss, and bandwidth. The third benefit is operational efficiency. Instead of configuring each branch manually, the IT team can use templates, centralized monitoring, and automated deployment workflows. The fourth benefit is resiliency. Multiple WAN paths and automatic failover reduce the impact of outages. Finally, the company gains growth readiness. New branches, cloud regions, and applications can be added using repeatable design standards instead of custom one-off configurations. The implementation should be phased to reduce risk. Phase 1 is assessment, lasting about 4 weeks. During this phase, the team should inventory devices, review current circuits, identify critical applications, baseline performance, and document existing routing and security policies. Phase 2 is the pilot, lasting approximately weeks 5 through 10. The company should select 2 or 3 branches that represent different network conditions. The pilot should test application routing, failover, security policies, monitoring, and support processes. Phase 3 is the core rollout from months 3 through 6. In this phase, branch deployment happens in waves. The team should avoid rolling out every site at once. A wave-based approach makes it easier to identify issues early and apply lessons learned. Phase 4 is optimization, around months 7 and 8. This is where policies are tuned, unnecessary circuits are retired, documentation is finalized, and performance reports are reviewed. Okay. There are several risks that must be managed during the transition. The first risk is skill gaps. SDN and SD-WAN require new knowledge in automation, centralized policy, overlays, controllers, and security integration. This can be mitigated with training, vendor workshops, and lab validation before production changes. The second risk is migration downtime. This can be reduced by piloting first, scheduling changes during approved windows, and maintaining rollback plans. Third risk is policy error. Because SD-WAN policies can affect many sites, a mistake could cause application disruption. To reduce this risk, the team should use templates, peer reviews, staged deployment, and monitoring. Budget variance is another risk. Organizations should phase spending, measure return on investment, and only retire circuits after performance is proven. Security exposure is also important. Controllers, APIs, and management interfaces must be protected with MFA, role-based access control, segmentation, logging, and patching. Centralized networking creates major benefits, but it also means the controller and management plane become high-value assets. The controller should be protected with multi-factor authentication, role-based access control, restricted management access, patching, configuration, backups, and redundancy. Administrators should only have the permissions they need to perform their job. Traffic should be protected using encrypted overlays, segmentation, secure internet breakout, threat inspection, and cloud security integration. This ensures that the organization does not sacrifice security while improving performance. Operational governance is also critical. The team should use change review, standard template, role separation, audit trails, seam logging, and documented rollback procedures. The key point is that SDN and SD-WAN must be treated as both networking and security initiatives. The goal is not only to move traffic more efficiently, but also control and protect that traffic consistently. This project is more than a technical upgrade, it is a business transformation effort. A successful SDN and SD-WAN deployment changes how network teams operate. Instead of spending most of their time on repetitive device configuration, engineers can focus on policy design, automation, monitoring, optimization, and security. Leadership is important because this transition affects multiple teams. Networking, security, cloud, service desk, operations, and business stakeholders all need to be involved. Clear communication, training, and change management will help reduce resistance and increase adoption. This approach also supports innovation. A standardized, automated network makes it easier to open new branches, support cloud applications, improve security, and respond to changing business needs. My leadership vision is to build a network operating model that is automated, observable, secure by design, and ready for cloud-first growth. In conclusion, the organization's current network is becoming too expensive, complex, and difficult to scale. Traditional WAN architecture is not flexible enough to support the company's growth, cloud adoption, and branch expansion without increasing cost and operational burden. My recommendation is to approve a controlled SD-WAN pilot focused on measurable outcomes, including application performance, WAN cost reduction, uptime, and operational efficiency. The pilot should validate policies, application routing, security integration, failover, and support procedures before a larger rollout. After the pilot, the organization can expand SD-WAN across branch locations and gradually introduce SDN into the core data center and cloud-connected environments where it provides the most value. Overall, the SDN and SD-WAN provide a modern, scalable, secure, and cost-effective foundation for the company's future growth. This strategy allows the business to move away from reactive network management and toward a more automated, policy-driven, and innovative network model. Thank you for your time. I am happy to answer any questions from the executive team. Thank you, and have a good day.